So now we're going to move on to solving linear systems. We're going to do this first by graphing and then by other means later on. So when you solve a linear system, what you're doing is you're trying to figure out where two lines cross on the graph. If you look here, if I were to graph these two lines, they would cross at one particular point, and that would be the solution for both of them where it crosses at that one point. And most linear equations have only one solution, and we'll get into the exceptions a little bit later. So if you see here, if I want to test if -3, I'm down here now, -3 and 1 as a point, if I wanted to test to see if that is a solution for this system here, what I'm going to do is I'm going to plug in the values and see if they work for both the equations. If they work for both of them, it is a system, it's a solution to the system, and if they don't, then it's not. But it has to work for both, so let's try it. So all I did was I plugged them in, and yes, -3 plus 1 is equal to -2. So yes, that is a solution for that equation. That means it's on that line. And then -3 plus 5 times -1, it's going to be 5. So -3 plus 5 is equal to -2. So that's also a solution. So that means it's a solution for the system because it works for both of them. So here we have a system of linear equations I have up here. -x plus y is equal to -7, and x plus 4y is equal to -8. So what I'm going to do is I'm going to graph both of these and see where they cross, and that will be the solution of both of them, and that's the solution of this system of linear equations. So what I'm going to do is I'm going to use these, since these are in standard form already. I'm going to simply figure out the intercepts of each of the lines. So here I found the intercepts when x is 0 and when y is 0, and I now will be able to plot those points. So I plotted those points. Now all I'm going to do is I'm going to draw lines and see where they cross. So after graphing them, you can see that the point where the two lines meet is going to be 4, -3. We're going to plug that into both equations and see if that's true. And in both cases, yes, it's a true statement because I just went ahead and plugged in this point into both those, and that does work, so that's a way of checking your solution. For these two equations, the lines are in slope-intercept form, so we're still going to graph them the regular way. We're just going to have to do a little bit more work in setting them up, and we're going to have to graph like 3 points instead. So let's do that. So I just went ahead and used the y-intercept here to start, and then after that I used the slope. In this case here, the slope is going to go down 1 every time you go over 1. In this case here, the slope is going to go up 2 every time you go over 1. So that's how I came up with these equations. So let's plot the points and see what the lines look like. So that's how the points look on the graph, and then I'm just going to connect the dots and see where they cross. That's for the top line, and that's for the bottom line. So where do they meet? They meet at the point 4, 0. Once again, we're going to check that up on top here and see if that's correct. And they check out for both of them because all I did was, again, I plugged this point into both of these original equations here. Works for the top one, works for the second one, so that makes sense as a solution. So in this problem, I have 3x plus 2y is equal to 6, and then x is equal to 4. Those are my two linear equations. And I'm just going to plot those quickly. I've already done it, as a matter of fact, using intercepts for that blue line there. So it's going to be when x is 0, y is 3. When x is 2, y is 0. And if I graph that, it's going to look like this. So that's my blue line. And that's my red line. And if you look there, I'm going to go ahead and circle this point right here. That would be the closest point. So that point, it's always going to be a little bit hard when you're graphing to be precise, so you need to use a ruler on these. But let's see if that point works. So that would be 4, -3. If that works for both, then we've got our solution. And On the, obviously on this first one here it works because x is just equal to 4 and 4 is equal to 4. So I know it's going to work for that one. Let's try the other one up here. So if I do that, it's going to be 3 times 4 plus 2 times negative 3. Is that equal to 6? Well, this is going to be 12 minus 6 is equal to 6. So yeah, so that's the solution. 4, negative 3 is going to be the answer to both. So it's the answer to the system of linear equations.